Hi there, my name is Saeid. I'm with Prep 101. In this primer, we will talk about basic limits. Limits is one of those topics that will be covered before your first midterm in Math 1 ZA3 at McMaster. You need to know how to calculate basic limits, how to recognize indeterminate form, and the meaning of the limit on a graph. Okay, let's get started.
We're going to talk about the idea of the limit. So if I have a function and I have this point A, and the function has this graph, the question is, what is the value of the function at A? So the value of the function at A, as you see here, is this value B. So what we write is f of A is equal to B. This value, which I can call it C, because of that hole that I have, that does not represent the value of the function at A. But sometimes we're not interested in the exact value of the function at a point. We're interested in the behavior of the function in the vicinity of that point. So we want to know what happens as you approach that point from the right side, or what happens to the function as you approach that point from the left side. Sometimes this is just the behavior of the function at that point. If you have some sort of discontinuity or an asymptote or things like this, the limit of the function, which basically represents the behavior around that point, might be different than the value of that function. For example, if I ask you to find limit of f of x as x approaches a, the question you would ask me then is, okay, what do you mean? What information are you looking for? Because the behavior of the function on the right side of A is different than the behavior of the function on the left side of A. At that point, I need to specify whether I'm approaching A from the right side, that's when we use a plus, or we are approaching A from the left side, that's when we put a negative. Don't say from the negative side, because A from the left side doesn't necessarily give you a negative value. So this value would be, if I try to approach A from this side, and as you see, the value would be B. So I say the answer is B. And if I approach this function if I approach A from the left side, then the value that I get on the y-axis would be C. So this is the general idea of the limit. And as you see, the value of the function at A is B, which is equal to the left side limit. When the lateral limits are different, so as you see, this number and this number are different, we say the limit of f of x as x approaches A from the right side is different than limit of f of x as x approaches A from the left side. And as a result, limit of f of x as x approaches A does not exist, simply because the lateral limits are different. This is the general idea of the limit using the graph. But most of the time, we're interested in the value of the limit, or we're interested in evaluating the limit. So the first step to find the limit is to plug in. So always substitute the number first. That means if I give you what is the limit of 1 plus sine x divided by cosine x as x approaches 0. Well, the first thing you should do is to substitute this number right in here and in here. Depending on the answer that you will get, you will decide what to do next. So if I substitute this number, I get 1 plus sine of 0 and cosine of 0, which gives me 1 plus 0 over 1. That means the answer is equal to 1. But sometimes the problem is not this simple. So they can give you what is the limit of x squared minus 4 over x plus 2, and x approaches negative 2. If you substitute the number like before, if you substitute this negative 2 here and here, what you would get is negative 2 squared minus 4 and negative 2 plus 2. So that essentially gives you 0 over 0. Now, that doesn't mean we don't know the limit. That doesn't mean the limit does not exist. That simply means we don't know what the answer is. So I would say the value that I get after substitution is 0 over 0. And we call this limit indeterminate. If a limit is indeterminate, you need to use a variety of techniques to evaluate that limit. The first thing that we usually do when we get 0 over 0 is to try to simplify and cancel. So in this limit, I can factor out the numerator. I get x minus 2 times x plus 2 over x plus 2 as x approaches negative 2. You see here that I can cancel out these two numbers, and then I get limit of x minus 2 as x approaches negative 2. This is a new limit whose answer equals the previous limit. So now I just substitute, because that's my first step again, and I get minus 2, that is negative 4. Now let's do a little bit, an example that's a little bit different. So let's say I have limit of x plus 1 under a root minus 1 over x as x approaches 0. So when I substitute 0 again, that's always my first step. Again, I get 1 minus 1 on top and 0 at the bottom. So I get 0 over 0, that is indeterminate. Now, I cannot really cancel anything here. Whenever you get a root, either on top and bottom, and you get 0 over 0 when you substitute, usually the technique that we use is multiplying by the conjugate. And I'm just going to rewrite this limit as x approaches 0. And I'm going to multiply this by the conjugate of the side that has the root. So in this case, it will be x plus 1 over the same thing. Obviously, when you multiply by the conjugate, you're going to multiply the top and bottom by the same number. And the way I got the conjugate is I got these two terms, I just changed the sign in between, so I put a plus in here. Now, using the identity that says a minus b times a plus b, that gives us a squared minus b squared, I'm going to use this identity. So now this would be a, this would be b. So this is a, this is b, this is a, this is b. So now if I use that identity, I get limit of the first term to the power of 2, so that just takes away that root, minus b to the power of 2, which is just 1 squared, that is 1, over x multiplied by square root of x plus 1 as x approaches 0. So you see here that these two cancel out, and this gives me limit of x over x square root of x plus 1 as x approaches 0. Obviously, if you substitute 0 here, again, you're going to get 0 over 0. But you can see that I can cancel out these two x values. And now if I substitute, I get 1 on top. And then I get 1 plus 1, which is 1/2. So that would be the answer to the limits.
I hope that you found this useful. If so, check out more foundations of first-year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems and how to do that with confidence and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.